On this topic, I'm all ears. Okay, that didn't go over that well. Seriously, this is actually pretty much how I've looked since I was 10 years old. But what if it had gone differently? What if we had actually solved this problem, and that might have been how I looked? If we had identified what exactly causes baldness, there might actually be something in that, and I could have been that guy. All right, I'm going to get Dr. Angela Cristiano in here. She is the lead author of this exciting study that we've been talking about. We've sort of been talking about it tongue-in-cheek, but it's actually a very, very serious study. She joins me now. She's a professor of dermatology and genetics and development at the Columbia University Medical Center. Joins me now. Thank you for joining us on this. Tell me about why you're even researching this.
Thanks, Holly. Nice to have me on the show. I appreciate it. We do hair research in my lab largely because I'm also a patient affected by hair loss. So I have a disease called alopecia areata, where the hair follicles come under attack from the immune system and causes the hair to fall out. So we started working on this in my lab about 10, 12 years ago just for that reason, because of my own self-interest.
All right, and so you sort of sound like you told me why you know you suffered from it, or is that generally why people suffer from hair loss? Is it the same trigger?
So alopecia areata is actually a fairly common form of hair loss. It affects about 4 million people, but that's really a small fraction compared to what we think of as common male or female pattern hair loss, which can affect as much as half the population. So
wow.
These are large, groups of people that care very much about their hair. So those are two examples of what we call polygenic diseases that are caused by more than one gene.
Mm-hmm.
But sometimes we take a different approach, like we did in this paper, to study families that are outliers that have a rare form of hair loss that can actually give us traction to understanding some of the more common forms.
And who did you look at? You specifically looked at people who experienced hair loss at a very young age. Is that what the starting point was?
Yeah, so our studies often start using a classic genetic approach where we find a family somewhere in the world who has a very severe and easily identifiable form of hair loss, in this case from one generation to the next. And we basically take a needle in a haystack approach. We look across all the chromosomes for a place where we see that everyone shares the same gene. Mm-hmm. Then we go in, identify that gene, and find a mutation or a change in the gene that's responsible for their hair falling out. In this case, what was very interesting to us was that the change that happens in the hair follicle of these rare patients is actually very, very similar to the shrinkage that occurs, or miniaturization that occurs, in common pattern hair loss. So there's a clear connection there, and this change in the structure and the shape and size of the hair follicle is something that is a big part of male pattern hair loss, and something that would be great to understand at the gene level.
Now tell me, that I was discussing this with our senior medical correspondent, Elizabeth Cohen, a little while ago, and she says when it comes to genes, understanding how it happens is the first step. What does that lead to? Does that necessarily lead to a cure? Are we looking for a cure? What happens? What's the implication of this?
So in this case, we've identified a pathway called the Wnt pathway that we've known for years is important in mouse hair growth, but we didn't yet have a clear connection to the pathway in human hair growth. And so that's a big step right there. Mice don't get male pattern baldness, and that's been a real limitation in our ability to study the process in the lab, or even to screen for drugs that might affect it. So a gene gives us sort of a starting point, a jumping off point for thinking about pathways and new ways to hit those pathways. So up to now, most of the work done in pattern hair loss has been about hormonal pathways, or DHT, testosterone-driven. This gene gives us sort of a new way of looking at it and suggests that some of the developmental pathways that are responsible for growing hairs in the first place are also playing a role in this shrinkage or miniaturization. So anytime we find a new gene that affects any part of hair growth, there's always new hope that eventually a therapy might come from targeting those different bits.
So basically,
but just to point out one distinction.
Yeah, go ahead.
Yeah. No, all of the genes that have been discovered for hair are actually terrific targets for the opposite problem of hair removal. So there, believe it or not, are as many people that are troubled by excessive hair growth as there are people who want to grow new hair. So I think that using these genes as targets for something like hair removal is actually closer at hand. And sure, all of them, I think, point us closer to therapies down the road in the
scientifically,
future.
I have to stop going around and telling people that the reason I'm bald is because I have excess testosterone, is what you're telling me.
It's as good an explanation as any.
All right. What a great conversation. Serious topic, but a great conversation. Thank you so much. Dr. Angela Cristiano, professor of dermatology and genetics and development at Columbia University Medical Center.